Hello, everyone. Thank you for joining for this session or watching this video later. This is basically going over a little bit of an introduction into the breadboard. We have covered this in our first lecture, but I understand that some of you are fairly new to this, so I want to go over it again. Okay, that way, and I can show you some examples of circuits and how you can build them. Now keep in mind there is no one way of building a circuit on a breadboard. If you understand how the breadboard works, how the connections are laid out in a breadboard, then you can come up with many different combinations or different ways of building the same circuit. Okay, what I'm going to show you is one approach or a couple of different approaches for parallel series and a composite construction, and then I'll go over how to integrate an amp meter and a voltmeter if you need to measure currents or voltages. All right. Okay, so just before we get started, let's identify the different parts. The breadboard building area is basically this part of the board, and we have 4 different terminals, and they typically have their own name: VA, VB, VC, and ground. They're just names on the board that are written. You can actually use them for different types of connections. Okay, the purpose of these connections are actually you can plug in a banana connector right into this connection interface. That way you can connect a power supply, a positive and a ground. So if you want to connect a positive and a ground, you can, following the color convention, you can do that. And now what we can do is, once you've made those connections, if you look closely, what we can do is we can actually open these up a little bit, and there's a little hole that you can slide a wire in. All right, you can slide a wire into those holes. Let me try to get this zoomed properly focused. So you can slide a wire in here, and that makes a good connection. And with that, so let's say I want to bring a ground into my board. So I would go ahead and connect the wire like this, tighten it, okay, and then I can bring this wire onto my breadboard. Okay, I bring it to my breadboard. Now I can connect it to my power supply ground, so that ground comes through and connects to this whole bus. You can see these blue and red lines. They are saying what they mean is they're saying these lines are connected. So the blue line, these little holes are all connected underneath the board. Okay, and then the red line, it's indicating that all these second row is connected across. All right. However, this red line is not connected to this line unless you make a physical connection, like through a connecting wire. You can make such a connection. Same goes for the blue line. They are not connected here unless you want to connect them across with a jumper wire. Okay. Now this way you can actually have a power supply run all around the board, or you can have different power supplies run on different buses so that you have access to them across your board. Okay, so that's a little bit about running your power supplies. Now the other key piece of information that we need to remember is that how are these holes inside the board are connected. Okay, so you can see that these A, B, C, D, E, right? For each part, there are 3 portions, 3 segments, and each of them you see A, B, C, D, E, and F, G, H, I, J. All right, and you can also see some numbers going down from 1 through 60, 61, 2, 3, 63. All right. Now, everything that has 1, so the row 1, row 1 here, okay, A, B, C, D, E holes of row 1 are connected together. Okay, and that's the only connection that is on here. And if you look at row 1, F, G, H, I, J, all those are connected. So for a given row, A, B, C, D, E are connected together. F, G, H, I, J are connected together to themselves only. The A, B, C, D, E is not connected to F, G, H, I, J. Right? So what this does is it creates, or it gives us the ability to use one of these rows as a node, as a form or as a place to connect multiple components, creating one node. Right? So and we'll look at a couple of examples here. So the key thing to remember, the key point on building a breadboard circuit is A, B, C, D, E. Those are connected together underneath the board. Okay, and F, G, H, I, J, those are connected. And if you place a component from A to E, that means it's not going to have any effect in your circuit because you have a connection, you have a short circuit underneath. All right, so keep that in mind, and I hope this is clear enough. And what I have done is for you guys, if you don't have breadboards at home, I've created this little PDF. You can actually draw how you would build it on a breadboard. Okay, again here underneath the board, these are connected and these are connected, and it continues all the way down. All the rows, the left half of the row, the holes, they are connected to themselves, not to each other. So these holes are connected up, A, B, C, D, E, they are connected, and that's it. They're not connected to anything else. All right, so all the way down there. And then again, if you see the red lines, you see the red connections and the blue connections like that. Blue, all the blues are connected all the way to the bottom. All the reds are connected all the way to the bottom. Okay, so now you can use this to draw a circuit if you don't have your breadboard. All right, so I hope that's a little bit of good information. Now what we can do is we can actually go ahead and start building a very simple circuit. We'll build a simple series circuit here. So let me grab my resistor box, and we'll build a series circuit that looks like this. Okay, so we'll build the series circuit, and I'm going to choose some random resistors here. Resistor box might be the same value. Yeah, so some resistors here. Okay, now if you look at this, so this is a series circuit. Series circuit, that means all elements are in series. If you start from this side, you go around the circuit, you have one single path to travel. Okay, if you want to apply a power supply to this series circuit, you would apply across these 2 points. Okay, now what we need to remember is we need to choose nodes, or we call them this is a node, considered a node. Okay, so we need to choose what we want to place in a given node, right? So we have 1, 2, 3 nodes in our circuit, excluding this power supply connection. All right, so we need to choose 3 independent rows on this board to place our circuit. You can build it in the middle, no problem. So let's grab 3 resistors. So I'm going to get 1, 2, and 3. So I have 3 resistors. Now we need to choose three different rows here. So, three different rows, right? And so I'm going to choose this row first of all, okay? And I can build it going down, right? So I'm one side is this node. This is the second node, okay? And then from that node, I have a second resistor, okay, going into this node. All right, from there, I have another resistor going into another node. You can choose any node in between as long as it's not being used. And so we have 1, 2, 3, and then this one we have one last from here to here. Okay, so we've created our series circuit. Okay, and this is not the only way to build this circuit. All right, so let me keep this on the side. I hope you guys can see it. If you want to build it this way, this is also valid. Because see, one node on one side, the other node on a different row, therefore these two are not connected. Okay, and then I can take this resistor and say, hey, how about like this? Still a valid connection. Okay, and then from here, I do need to connect to the same node. I have to start from that node where we ended our previous circuit or previous resistor. I build my next, place it in the next row. Okay, then I'm going to grab this, and then you can build it like this. See? The key point is you need to have the two terminals in the same row, or two leads on the same row, so that you have that closed connection through the resistor. Now, if you are to go and place your resistor like this, see, it's the two leads are on the same row. Now, that will nullify the effect of the resistor, because you have lesser resistance. There's a short circuit, so the effect of the resistor disappears. So we need to be very careful to avoid such a thing. Okay. All right. So now let's say I have this circuit built, okay, and I want to apply voltage to these inputs. Okay. So what I would do is I would grab a couple of wires, and so I'm going to use these terminals here. Okay. Be careful when you connect to these terminals. We need to make sure that we don't grip on the rubber part. We connect to the metal part. Okay. I can directly connect here, or I can create a bus. It's up to you. Okay. And then we'll get another wire. Since I have the bus connected already here, I'm going to connect it to this circuit. Okay. If you want to be clean, you can follow different methods. Some people run the voltages around the board. However, what we can do is, this is a very straightforward, simple approach. Now you can connect your banana to your power supply. Okay, so it runs through, goes through the circuit, and returns to the power supply. Very straightforward there. Okay, all right. So that's about series circuits. So let me disassemble this for now. Now, if at any point, I'm showing a couple of different circuits. If you want to test your knowledge, pause the video, try to draw it or build it yourself, and you can see what happens. Okay, so the next circuit is looking at a parallel combination. Okay, so there are different approaches you can follow. You can either treat each of them as a node, and then you'll need to interconnect the nodes, or you can use any of the row as a node itself. So this could be hole A, this could be hole B on the same row, and this could be hole C on the same row. All right, so I'll show you a couple of different approaches of building this circuit. All right, so if I am to treat the 3 nodes as separate rows, then what I'll do is I'll build this like this way. I have that. I have another row like this. They're independent, but we do need to connect them. Okay. Then I have another one like this. Now, in order to establish the parallel connection, I need some jumper wires, which I will use these. So we need to establish this connection, right? And then we need to set up this connection and this connection. Finally, one last connection. Like that. Okay, so now we have set up our parallel circuit. See, parallel circuit. This is easy to visualize. You can see how the resistors are laid out. Okay, now once you get more experience, you don't need to go to this level. You can actually do this. We can place them on the same node. See, you can place them on the same. Now let me see if I can zoom in a little bit. There you go. You can place them. See, they are right on. Yeah, see, they are on the same node. Okay, and I'm going to place this also in the same, in the 2 same rows. One here and one here. So we have to be very careful in this case. Because you don't want these to touch each other, could short things out. So we want that bottom board connection to be the only connection. All right, so sometimes this can be tricky, but this is again the same circuit that we built. Okay, you can connect them in that parallel manner, or you can connect them in this way in the same node. Okay, so let's go back to what we had, because I do want to show you how to connect an amp meter to the circuit. That's another essential part, essential component for circuit building. Okay, so I'm going to go back to my simpler parallel circuit. Okay, like that. Okay, all right, so we have the simpler circuit that we've spoken about. Now, let's say I want to measure the current going in through this resistor. All right, so if I want to measure current, we should by now know that, of course, we need to have a power supply. Okay, let's assume the power supply is connected, right? So we have our power supply connection like that. Okay, so there's current flowing. To measure the connection current here, we need to place our amp meter in series with the resistor. That means the current has to go through the amp meter and return through the resistor. Okay, so we have to place it in series. So in order to place an amp meter in series, you need to break that connection, right? And what we would do is we would grab one wire. This is going into the amp meter, and then we'll have another terminal coming out of the amp meter, and that return goes back to your circuit. So you need 2 terminals, and they need to be, we should have disconnected so that the current goes through that amp meter and returns to the circuit. That's important. A lot of people tend to forget that. Okay, so that's the important part. Now, let's say we set up an amp meter and we measured current. Now we need to measure voltage. Measure voltage. If you are to measure voltage, we place our voltmeter in parallel. In parallel. Okay, so that means you don't need to break connections in the circuit. You can place your voltmeter like that. Okay, so you can measure the voltages across these two leads, and it'll measure the voltage across the resistor. Okay, all right, and keep one more thing to keep in mind, depending on what type of meter you use. For digital multimeters, some of them you have to change terminals for current measurement. Some of them you don't, but make sure you have switched to the right settings, and then you have the dial in the run measurement scheme to get that appropriate reading. Okay, all right. So we built a series circuit, we built a parallel circuit, and then for the final step, what we're going to do is we're going to look at building a composite circuit. Okay, composite means it's going to have both series and parallel. Okay, so we have a combination here. Now you can grab any resistor with any value and pause the video, and you can go ahead and build this circuit yourself. Okay, and then you can compare with what I have, but I'm gonna go ahead and try to build this circuit. Okay, all right, so let's say I need 1 2 3 4 5 6 7 resistors. 1 2 3 4 5 6 7 resistors. All right, okay, let's build this. I'm going to just disconnect the power supply for now, and I'll use this area. So I have one resistor, and then I have a parallel connection. Okay, so I have one going down to the bottom, and then one connection. So we have 3 resistors connected at one node. 3 resistors at one node, right? The first 3. So that's this connection. Okay, and then let's build this connection. So I'm gonna get this resistor, and then I will build that connection. Okay, again, there are different ways you can build this. All right, so now we have this connection. Next we will build which one? So actually we can now build this node, right? So we have one resistor connecting from this node to this, right? So we have one connection like that. All right, and then we have 2 resistors after that. So we have 2 resistors connected between these two like that. So I'm gonna grab this. We have to place them in the same node, and then grab that, place it in that same node, and we're done. See, that's a composite circuit. It's that circuit. Okay, so it's, I know once you do several of these, this will come very easy. You'll understand very well what to do this. So that's why I encourage you to build them, or at least draw them. If you don't have a breadboard, that's fine. Get a sheet like this printed, or you can prepare it yourself, hand drawn, and build different configurations of circuits, or draw on that piece of paper to build up how the circuit works. Okay, all right, so hopefully this was helpful. Please let me know if there are comments, any feedback, anything I can do to improve the video, and thank you for watching.